We're sitting here by the Columbia ice field, which is one of the largest mountain ice fields in the world. And we're particularly interested in this ice field because the Saskatchewan glacier, which comes off it, is one of the headwaters of the Saskatchewan river system. The national parks in this area are one of the largest UNESCO World Heritage Sites in the world, but it goes beyond that. There's a practical benefit to studying glaciers is because of their contribution to stream flow. So water from these glaciers are used for food production, hydroelectricity production, and urban water consumption throughout the prairies. And because glaciers melt fastest during the hottest, driest summers, this provides a little bit of drought proofing for the prairies. And so when we need to fill those reservoirs in the most dire conditions, we still have some glacier meltwater to deal with. And that's an advantage that we have in Western Canada that most other agricultural regions in the world don't have. The temperatures in this part of the Rockies have risen several degrees over the last century, and the glaciers are some of the best indicators of climate change that is occurring. Where I'm sitting right now, a little more than half a century ago, would have been under many tens of meters of glacial ice. And right now, we're kilometers away from the edge of the glacier. Our particular interest from the university is advancing the science. And a particular need that we're trying to fill is improving models of glacier hydrology, glacier interactions with the atmosphere, so that we can better calculate what the future of this sort of environment is going to be and what the future water resources will be for Saskatchewan. We'll be flying a drone, call it the snow drone, and it's a unmanned aerial vehicle which will have thermal infrared measurements, near infrared measurements, and visible measurements to give us the snow-covered area. We'll be able to develop a three-dimensional image of the glacier so we can then map out the glacier change over time. And these three-dimensional elevation models we can develop with the glacier have an accuracy of better than 5 centimeters.